All of you keep your videos on again. Switch on your videos, everyone. Mahuri, can you tell me what are the three different effects of heat that I discussed yesterday?
Yes, sir. Um, Heat, it results in change in temperature, change of state, and change of size of the body.
Right. So there are three different effects that we did yesterday. The first one was changes in the temperature of the body. Right? You already know that when we heat a body, so if a body is heated, what happens to the temperature? Temperature rises, isn't it? And when the body is cooled,
Then it falls.
the temperature decreases, right? Now, because of these two changes, how does this happen? These are dependent on two factors which affect the rise and fall of the temperature of a body. We have two different factors which are there. The first one will be the quantity of heat which is being supplied. Okay. So how much of heat are we providing to the object? That is the first factor which will determine the rise and fall in the temperature. Okay. For example, what happens is when you impart a temperature heat to a body, its temperature rises because the molecules start vibrating faster. And if we take away heat from a body in which we have cooling a body, okay, the temperature falls because the kinetic energy of the molecules fall, right? So what happens is the average kinetic energy of the molecules increase on providing a greater amount of heat. So the temperature rises accordingly. Is this clear? So the temperature change will depend on one, the quantity or the amount of heat being supplied. And the second factor is the material of the body. You already know that we have done about like some materials, they absorb heat and some of them don't, right? So some of the objects, they when we heat them, their temperature rises quickly, whereas some objects, they are resistant to absorbing heat fast and the temperature rises slowly even with the same amount of heat. So depending on which material we are using, the temperature will change accordingly. Some of the temperature will change. Like for example, if I provide, let's say 100 kilocalories of energy or heat to the body, we will find that some material raises its temperature by 10 degrees Celsius, whereas another one will only raise it by 2 degrees Celsius, even though the quantity of heat applied being is the same. Okay, any doubts so far in this part? Any doubts, anyone? Please copy this down. That is the first one, changes in temperature, effects of heat. The first change is that it changes the temperature of the body. And how is it? It's directly proportional. And factors which affect the changes in temperature is basically two factors: quantity of heat supplied, or you can even say rejected or taken away, because we have to work on both, even heating and cooling and material of the body. All of you will quickly copy this before I go further. Done? Anybody still copying? Okay. The second effect of heat is to change the state of body. What are the three different states of matter that you have learned so far?
Liquid, gas.
Solid, liquids, and gases. So we already know that there is a change in state from one to the other depending on if it is heated or cooled. Right. So we have done this in detail. So let's quickly recall this. We have solid, we have liquid, and we have a gas. Solid to liquid on, let me put this in red. Red is heating. Heating a solid to liquid is called? What is the change?
Melting.
Melting, or what is another term for melting?
So fusion.
Correct, fusion. Liquid to gas. Sarah Patel.
Boiling.
Boiling, liquid to
Boiling.
gas, or
Boiling. Evaporation.
No, evaporation doesn't take place on heating. Evaporation is it doesn't depend on temperature. Vaporization.
Okay, just vaporization.
Vaporization, right? Okay. Mahuri, from solid to gas.
Sublimation.
Correct, sublimation. So these are all changes which take place because of the heating objects, right? So now let's go to the reverse part. Let me do it in blue again. Gas to solid. Sarah Vastani. Sarah Vastani, gas to solid. Sarah Vastani, are you there? Sia? Sia, are you there?
Hello, am I audible?
Yes, you're audible now, Sia. Sia, gas to solid, what is the process called?
Hello.
Yes, Sia, you're audible. What is the process of conversion of a gas into a solid called?
Deposition.
Correct. Sarah Vastani, what is the answer? Can you repeat it?
Yes, sir. It's a deposition.
Deposition. From liquid to solid, who wants to answer this? Siddhant Garve?
Yes, sir.
Liquid to solid, change of state from liquid
Freezing.
to solid. Freezing,
Freezing.
or solidification. Okay. And lastly, from gas to liquid. Siddhant Singhal.
Yes, sir.
Gas to liquid.
So condensation.
Condensation. Right, we've already done these kind of changes earlier. So what happens is the process of change from one state to another at a constant temperature is called change of state. Remember, the temperature does not change when there is a change of state. All of you all, please mark this up. The process of change of change from one state to another at a constant temperature is called change of state. Very important part is constant temperature. Please remember that in change of state, there is no change in temperature. Okay. That is why the boiling points, the melting points, everything is fixed. Had the temperature changed, what would happen is that the melting point and boiling points, everything, freezing point, everything would change as the solid is being converted from one form to the other. Right? So that is why ice at 0 degrees melts into water at 0 degrees. So if we have ice, which is at 0 degrees, when there is a change of state, it will convert into water at 0 degrees only. Please remember this, there is no change in temperature. Similarly, water at 100 degrees, if we heat it, what will happen? It will turn to steam at 100 degrees. Okay. Similarly, the other way around. Can you tell me that since this temperature is not changing, what happens to the heat which is being provided? Anyone? We've already done this earlier. We said that when we are heating an object, let's say we're heating water at 100 degrees and it converts into steam at 100 degrees, but I'm continuously providing heat. So why is the temperature not rising? Samita, can you tell me why?
Yes, sir.
Can you tell me why? When we heat water at 100 degrees Celsius, it converts into steam at 100 degrees Celsius, even though we are providing heat to it. So why does the heat that is being provided not increase the temperature of the steam? Do you know the answer?
No, sir.
Sia? We've done this earlier in one of the chapters. Sia, can you tell me the answer? Mahuri, Sia?
Due to latent heat.
Okay. What is latent heat, Mahuri?
Latent heat is a specific temperature that remains constant during the change of state.
No, that won't be the correct definition of latent heat. The temperature remains same. The temperature remains same of the substance. So what does the latent heat do?
So
Yes, yeah.
the latent heat converts it from solid into liquid or liquid to vapor without changing the temperature.
Yeah, it is the heat which is required to change the state without changing the temperature. So what exactly happens is that supposing now we have the solid over here, okay? We have water here. I'll explain it, everyone please understand. So we have these molecules of water which are spread a little bit apart. Now there are strong forces of attraction which are holding these molecules together, relatively strong compared to gases. Now whenever we heat this object, okay, it raises the temperature till 100 degrees, right? When the water reaches 100 degrees, what happens is there is a change of state going to occur now because the boiling point of water is at 100 degrees. So once it reaches the boiling point, this additional heat that we are applying is used to break up these forces which are holding the molecules together. This is called latent heat. Okay. So instead of raising the temperature of the liquid or the water, what happens is that this energy, which is being provided in the form of heat, is used up by the liquid or the water to break up the forces and converts into the change of state into a gas. Or in this case, it is steam at 100 degrees itself. So this additional heat that was being provided until we reach the boiling point was now taken up as a latent heat to break up the intermolecular forces holding the object in place. Right? And do you also remember what was the term which was used for this? This was called latent heat of vaporization. Similar to this, we had a latent heat of fusion when the solid changed into a liquid. Again, there is no change of state over there. Sorry, there is a change of state, but no change in temperature. So from solid to liquid, we'll have a latent heat of fusion. From liquid to gas, we'll have latent heat of vaporization. Is this concept clear, everyone? Please copy it down. So latent heat is nothing but the energy which is released or absorbed by a body during a constant temperature change process. And again, we can measure it. We'll be doing this in 10th, how we can measure the latent heat of an object, of both fusion as well as vaporization of different objects. Everyone, please keep your videos on. Please copy this down, everyone. Have you all finished copying? Anybody still copying here? Raise your hand if you're still copying. Okay, let's go further. Can anybody tell me the difference between evaporation and boiling? Come on, you all have done this
Yes,
earlier. Tell me.
Yes, sir. In evaporation, evaporation takes place at all temperatures, and boiling takes place at a specific temperature, which is its boiling point.
Yeah.
Then evaporation is a slow process, boiling is a fast process.
Specific
Then-
temp. Yes. Slow process. Correct. Continue.
Then evaporation, it takes place at the surface of the liquid, and boiling takes place at all parts of the liquid.
Yeah.
And then in evaporation, the temperature of the surrounding falls, and in boiling, the temperature of the surrounding remain constant.
Correct. And why is this? Can you explain why the fourth point happens?
So maybe because evaporation occurs at room temperature.
You just told me evaporation occurs at all temperatures. So how can it occur at room temperature?
I don't know.
Okay. Think of this. Now we have a glass of water. Okay. This is filled with water. Right? We have these molecules which are there at the surface. So what will happen is these molecules, they will absorb the heat energy or the latent energy from the atmosphere. And because it absorbs this heat energy from the atmosphere just above this area becomes cooler. Right? And this energy which it absorbs from the surface, just above the surface, is converted into latent heat, and it breaks up the bonds holding the surface molecules, and they evaporate into the air. Is this clear, everyone? Siddhant, is this clear? So
Yes, sir.
therefore, what happens is that the immediate layer of air above the surface of the liquid becomes cooler because its heat energy is absorbed by the surface molecules to gain latent heat and to break up the molecular forces which are holding them together, and that's why they evaporate and they escape the surface. This heat energy is not enough to penetrate deeper into the molecules of the liquid. Only the top layers therefore evaporate. That is why this thing is called that it's a surface phenomenon. Right? It's not a phenomenon which occurs throughout the liquid. It's only at the surface because it's a very small amount of heat energy there. Everyone, please copy this down. All of you all please copy this. Okay, are you all done? Anyone still copying? Raise your hand. Okay. Another way to explain this latent heat and why the temperature does not rise. Remember where I told you that we have molecules. So there are two forces or two kinds of energy which they possess. First is the kinetic energy because of the motion or the molecules vibrating or moving. And then we have the forces of attraction which are holding the molecules together, right? This is the potential energy. This latent heat that we have, basically what does this do? It raises the average potential energy of the molecules. So once the average potential energy increases, what happens is that the forces of attraction, they break down. The kinetic energy remains same. Or we can say that the average kinetic energy remains the same. And we know that the measure of average kinetic energy of a substance is called its, what is it called? Siddhant Garve, can you tell me what is the measure of average kinetic energy possessed by a body called? Siddhant Garve?
Yes, sir.
What is the measure of the average kinetic energy possessed by a body called?
So just a minute.
Don't you all revise before coming on to the lesson? It will take you 15 minutes just to go through the previous day's notes. Who can tell me what is the measure of the average kinetic energy of a body called?
Temperature.
Temperature, right? So now you understand
Yes,
that
sir.
because the latent heat only affects the average potential energy, which increases the average potential energy and not the kinetic energy, therefore the temperature does not change. Is this part clear, everyone? So only the average potential energy is changing, whereas the average kinetic energy remains the same on heating with latent heat. Remember, I'm talking only of latent heat. Don't get confused between normal heating and latent heat. Okay, I'm talking only of latent heat. Obviously, heating a substance will change its kinetic energy till its boiling or the melting points. But we're talking of the latent heat in which there is a interconversion of change of state. When there is a change of state, the latent heat comes into play, which increases or decreases the average potential energy, and therefore the temperature remains same because there is no change in the average kinetic energy. If you want, you can copy this kind of a diagram next to your book so that you can remember this. The third is the change in size or size of the body. This is apparently very easy to understand. When we heat an object, what happens? The molecules, they spread apart. Therefore, the body size increases. And the reverse happens on cooling, right? So generally all solids, liquids and gases, they expand on heating and contract on cooling. So what happens is the molecule spread, that is the intermolecular spaces, increases. Right? And in cooling, the opposite happens. So please continue and write down for cooling also. Please copy this down. This is the third effect of heat on a substance. Everyone done? Is anybody still copying this? Raise your hand if anybody is still copying. Okay, now one more important aspect to remember is the effect of temperature on molecular motion and the concept of absolute zero. What exactly is absolute zero? Okay, so what did we say? That when we heat an object, its molecules, they gain kinetic energy and the motion increases, isn't it? So now that means on the reverse side, if we cool a body, what will happen? What will happen to the molecules? Anybody? Is everyone sleeping? Even I would like to go to sleep now. If I don't receive answers, I will not continue. Anyone, unmute yourself and tell me what happens to the molecules when I cool a body?
Temperature decreases.
Temperature decreases, but what happens to the molecules? What happens to the motion of the molecules, Siddhant?
The molecules come
So they
closer.
contract.
Molecules don't contract. That is incorrect.
So the molecules come closer.
Yeah, but what happens to the motion of the molecules? Molecules come closer together, but what happens to the motion? Will they increase this motion or decrease the motion?
They decrease their motion.
Motion decreases. So if we think now, if the motion is decreasing, I have a molecule which was, let's say we are talking of a solid now. It was vibrating fast, right? On cooling, what happens to the motion? It will decrease. So it will only vibrate so much now. So if I continue cooling further, shouldn't there be a point in which the motion itself will stop and the molecule will stop vibrating? Or we can say the molecule stops motion. Shouldn't this logically be the case? Yes or no? Mahuri, yes or no? Mahuri, unmute yourself.
So could you please repeat your question? You were inaudible for like past 2 minutes to me.
I said that when we cool a body or an object, its molecule motion decreases. Yes or no?
Yes.
So if we continue cooling, shouldn't there be a point in which the molecules stop motion at all and they completely become still? Isn't that logically what we should think?
Yes.
Right? So as we further cool an object, the motion of its molecule will continue to decrease until there will be a point in which the molecule stops motion completely. This temperature at which molecular motion stops or becomes zero is known as the absolute zero on the Kelvin scale. Okay. So this is the temperature at which a body or its molecules will completely stop vibrating. So even if it's a gas, we cool it, it will turn into a liquid, it will turn into a solid, and even in a solid, the molecules will stop vibrations completely. This is the minimum or the least temperature that we can reach. You cannot go at a temperature lower than absolute zero. So a temperature lower than absolute zero is not possible, because there is no motion of the object, of the molecule. So if there is no motion and we cannot then stop vibrating more, so how will we decrease the kinetic energy? So the temperature cannot fall. Is everybody clear on why a temperature lower than the absolute zero is not possible? And what exactly is absolute zero? Yes or no, please answer. Absolute zero is 0K or minus 273.15 degrees Celsius, or it can correspond to minus 459.67 degrees Fahrenheit. Please copy this down. It corresponds to 0 on the Kelvin scale, minus 273.15 on the Celsius scale, and minus 459.675 on the Fahrenheit scale. Okay, please understand the concept of absolute zero. How does it work and why you cannot get a temperature lower than absolute zero. Sarah Potter,
Yes, sir.
can you explain to me why a temperature lower than absolute zero is not possible?
It's a temperature lower than absolute zero is not possible because I don't think anything could be even getting even colder than that specific point.
Why? That's what my question is. For the past 5 minutes, I've been explaining the same concept. Were you not listening?
The molecules stop.
Exactly.
The
Yeah.
motion of the molecules stop.
Right. So the kinetic energy decreases to a point in which there is no motion. temperature is directly related to the kinetic energy of possessed by molecules. Since there is more motion, there will be no more kinetic energy to further decrease. So the temperature cannot go further down, right? So you need to now explain in the terms of theoretical concepts like molecular energy, molecular motion, kinetic energy, and how temperature is related to kinetic energy of the molecules. Okay. Is everyone clear here? Sarah Bastani, again, say there is no further movement of the or molecular motion of the molecules. Okay, use these keywords. Without these keywords, you will not be getting marks. Please copy this down, everyone. Okay, that's it for today. I'll be probably starting biology tomorrow.